Okay, this is day 2 of factoring quadratics. Remember, quadratics are in this form: ax squared plus bx plus c. And today we're going to look at ones where a is a prime number. Okay, yesterday, all the ones we did, a was 1. So now a can be a prime number, something other than 1. And we'll see how we do those. So let's look at the first one. And this method does take more work. It's more involved than the one we looked at the other day when a is 1. Okay, so we start out by finding two numbers that add to b and multiply to a times c. So in this case, for the first one, the numbers we're looking for add to negative 11, because that's our b term, right? Our coefficient of x. And they multiply to 18, because that's a times c. Okay, 3 times 6 is 18. So we'll work on finding those numbers. So we have 18. We'll write the factors of 18, like 1 and 18, for example. 2 and 9. But of course, that adds to 11, but we need to add to negative 11. So we recognize it's going to be two negative numbers, right? Negative times a negative is a positive. So negative 2 and negative 9 multiply to make positive 18, sure enough. But when you add them together, you get negative 11. So that's the numbers that we'll use. We found them. So this method is sometimes called the AC method, because you have that product a times c. It's also sometimes called split the middle, and you'll see why. We use these numbers, and we are going to express that middle term of negative 11x as negative 2x minus 9x. Okay, that's why the numbers have to add up to 11, is that we're going to split that middle term. So you'll see what that looks like. 3x squared, and then we say minus 2x minus 9x plus 6. So we just rewrote this, and that took the place of the negative 11x, which of course negative 2x minus 9x equals negative 11x. So now the reason we do that now is we will factor this part of it by pulling out the greatest common factor, and we will factor this by taking out the greatest common factor from it. So let's look at the one on the left, the greatest common factor. And this is why we had to do the practice on greatest common factor. It's just x. Okay, the numbers are both prime, 3 and negative 2. We can't factor out a number, but we can factor out x. Okay, and then let's look at the greatest common factor of this one. And that is negative 3. We cannot factor out an x from both of those. 6 doesn't have an x to factor out, but we look at the numbers and we can factor out negative 3. Okay, we could make that 3, and that would make a little more work later. If we pick the wrong number, we may have to go back and do it again. That is, if we used 3 instead of negative 3, then we would see that negative 3 is the one that actually works. So you'll see what I mean. So let's go back to the box on the left. We said the greatest common factor is x. So we need to see what's left after we factor out the x. You can do this in your head, but we're going to show what we're actually doing. Divide each of those terms, okay, that term and that term, by x, because that's our greatest common factor. And so we get what's left. The first term is 3x, and the second term, it's just 2. So now we know that when we factor out the x, we're left with the 3x minus 2. So there it is, with the x factored out. We could have just looked at this and said, well, we're factoring out an x, and that leaves 3x, and we factor out an x from that term, that leaves negative 2. It's fine to do that. I just wrote this out to show what we're doing mentally when we do that in our head. We multiply this back, of course, to check it. X times 3x is 3x squared. And then that's the x times the 3x, right? And then the x times negative 2 is the negative 2x. Okay, so we do the same thing over here. Greatest common factor is negative 3. So negative 9x divided by negative 3 plus 6 divided by negative 3. And that gives us uh, 3x. Let's see, negative 9x divided by negative 3 is 3x. And 6 divided by negative 3 is minus 2, negative 2. And of course, what we factored out was the negative 3. Okay, so what we've done is we've rewritten this polynomial after splitting the middle. We split the middle term into these, right? And we've rewritten it as this down here. Okay? By simply factoring out an x from that first half and negative 3 from the second half. And this is where the magic happens, because now we can factor out this binomial. Okay, that entire binomial is a factor of the product, you know, on the left, x times that binomial, and then it's also a factor of this product here, which is 3 times the binomial. So it's very cool. We now factor that binomial out. Whoops. And move this up a little. Okay, and we get that. Okay, factor the binomial out of this product, and it just leaves the x, right? Factor that binomial out of this product, and it leaves the 3. And so to check that, we can multiply this binomial, okay, we distribute it. Take it times the x, take it times the 3. Okay, and when we do that, we see, sure, we take that binomial times x, we get this, kind of crowded here with all my underlining. And then when we take that binomial times negative 3, we get this. So if you multiply it back, sure, you do get that step before. So we have now factored that thing. And of course we can check it, multiply it out all the way now to see if we really do get our original quadratic. So let's go ahead and do that. 3x times x, 3x squared, 3x times 3, negative 9x, and then negative 2 times x, negative 2x, and negative 2 times negative 3 is positive 6. So this is pretty neat. You see, when we did this, we get the same thing back there that we split the middle into. So when we split that middle, we got negative 2x, negative 9x, and that's what we have here. They're in the other order, but that's okay. So you don't have to notice that every time or anything. The method just works, and that sort of shows why it works. Okay. Let's get rid of some of this extra stuff. So I won't leave that where we checked it. I won't leave that in the notes. We'll just leave it like that. And there it is. It is now factored. So let's look at another one. So we do the same thing here. Let's call it the AC split the middle method. That way the name of the method has the entire process really. AC split the middle. So they're going to add the numbers we're looking for, are going to add to negative 4, and they're going to multiply to AC, remember? That's A times C, so that's 7 times negative 3, which is negative 21. So we find these numbers. And we'll kind of work over here to find the numbers. They need to multiply together to make negative 21. And they add together to make negative 4. So this time they're multiplying to make a negative, so it's going to be a positive and a negative. And they have to add to make a negative number, so the larger absolute value will be the negative one. So we think about that. Let's just get pairs where we have a positive times a negative, and where the larger absolute value is negative. And we have this, and of course that won't work. That multiplies to make negative 21, but it does not add to make negative 4. But 3 and negative 7, that's the one, right? So that does add together to make negative 4. So we've got our pair. We're going to split that middle into 3x minus 7x, because that's our numbers there, 3 and negative 7. So here we go. 7x squared plus 3x minus 7x. Split the middle, right? That adds up to negative 4x. And then minus 3. And then, now that we split the middle, we can factor these two boxes here. First one, GCF, is x. Can't take a number out, just take out the x. And here, the greatest common factor is just negative 1. Okay? So if we just if we did not take out the negative, we would end up with the wrong sign. If you look at this, there's a negative here. See where I'm right here? So when you have that, makes sense to factor out negative, okay? So let's now divide 7x squared divided by x plus 3x divided by x. And over here it's going to be negative 7x divided by negative 1 and negative 3 divided by negative 1. Okay, so we factored out this x. We said that's our greatest common factor is x. So we write that on the outside, and on the inside goes the 7x squared plus 3x. And here we factored out the negative 1, and on the inside goes negative 7x minus 3. Okay? Oh, no, wait. 7x plus 3. I did that wrong. Well, I did both of those wrong. Sorry, let's erase that. I put the unfactored part in there. Sorry. Getting tired. So, sorry, inside here goes whatever we get when we divide 7x squared divided by x, which is 7x. And we divide 3x divided by x, that is 3. Okay, and over here, we have the negative 1, and when we divide negative 7x divided by negative 1, that's when we get the 7x. And negative 3 divided by negative 1 gives us 3. So like magic, we get the same thing in here. If you don't have the same thing in there, then it didn't work. You have to figure out what went wrong. But we do have the same thing. So we factor that binomial out from each of these products. We factor it out of that product. We factor it out of that product. So we factor it out of the first one. 7x plus 3. It leaves the x. This x here is what's left. And then factor it out of the second one, and we're left with negative 1. Okay? So that's it. We're done. And if we FOILed that out, we would see that it does work. Okay, we have one more. See if I can do this without making a mistake. Well, I've already messed up my sketchbook. Okay. So here we go. So this time they're going to add to make that middle term, right? The b. They're going to add up to negative 5. And they're going to multiply to negative 24, which is a times c. So hence the name, the AC method. But we call it the AC split the middle method. Once we find those numbers, we'll split the middle. So let's find them. What multiplies to make negative 24? It adds to make negative 5. So again, we got to multiply to make a negative number. So it will be a negative and a positive. They add to make a negative, though. So the larger absolute value will be the negative. So we only need to look at pairs with the larger absolute value being the negative. And we can see what that's going to be, right? Negative 8 and 3. Because the larger absolute value is the negative 8, in this case negative 8. Negative 8 plus 3 is negative 5. So we've got it. So we're going to split that middle term. It's currently written as negative 5x, but we're going to split that into the plus 3x and minus 5x. All we did was rewrite our quadratic, but with negative 5x split into those two pieces because, oh, I wrote down 5, it should be 8. Sorry about that. Just turn that into an 8. That's going to combine to make negative 5x, right? We found the numbers that make it work. Negative 8 and negative 8 and positive 3. Okay, make that an 8. Okay, so now we got to find greatest common factor. The idea is the reason we split the middle is so that we can find that greatest common factor and factor it out. So of this one, it is 3x this time, right? We can take out the number 3 and an x from both of those. Here, we can take out negative 8. So, let's see what we get. 3x squared divided by that 3x plus 3x divided by 3x. And let's go ahead and do that. Taking out the 3x squared, or the 3x, we get everything cancels here except for x, right? 3x squared divided by 3x is x. And then here 3x divided by 3x is 1. Okay? If we multiply this back like this, we should get back to that. And we do 3x squared plus 3x. Okay? Checking that as you go sometimes just helps eliminate some errors. Okay, so now we'll look at the other side, the rest of the expression. The greatest common factor was negative 8. So we have negative 8x divided by negative 8 minus the 8 divided by negative 8. Okay, so taking out the negative 8, it's going to leave whatever this quotient is here. Negative 8's cancel, so that's x. And here, minus 8 over negative 8, it comes out to positive 1, right? Okay. So it worked. That's great, and we know it worked because we have that binomial as a factor of both of these products. So we factor it out. and it leaves 3x here and negative 8 here, and that's it. 3x minus 8 times x plus 1. We could FOIL that, and we should get this back, and I think we do. So that's a few examples. So you'll get to practice on these. Remember the AC split the middle method. Find the numbers that multiply to a times c and they add to b, and then split that middle term. And then find the greatest common factor in the first two terms, which is here, and find the greatest common factor from the last two terms. Factor out that greatest common factor, and once you do that, if you didn't make any mistakes, you'll be able to factor out a binomial, because you'll have that same binomial as a factor of both products. Now, that, of course, this only works when the original quadratic is factorable. So there could be some that they're called prime, and you can't factor it. It just will not factor into these binomials with whole numbers. So yeah, if there's one of those, you won't be able to do it. It just won't work. So hopefully that will be enough to get you going on the homework, and see you tomorrow.